Hello my friends and welcome to the practical activities of this Artificial Intelligence A to Z course. My name is Adlan de Ponteves. I'm the second instructor of this course who will be doing all the practical activities with you. And the reason I'm starting from this Gmail page is because I want to do everything from scratch so that you don't miss any step while setting up your AI environments. Alright, so as you can see, I literally just created this new email address, artificialintelligenceatoz@gmail.com, because indeed we will be building the different AIs of this course in Google Colab. And in order to implement code in Google Colab, well, you need a Gmail address. So that's why please make sure to at least have a Gmail address. I just created one. It took me a few minutes so that we can set up Google Colab. And now, why did I choose Google Colab to implement the AIs together? Well, that's for a very simple reason. It's just in order for us to not have to install any packages, because if we implement this, for example, in Jupyter Notebook or another IDE like Spider, we will have to install a lot of packages and this will be a lot of hassle. While if we implement the codes of our AI in Google Colab, well, you will see it's super easy because in Google Colab Notebooks, you will see that most of the packages we'll use are already pre-installed. For example, PyTorch is already pre-installed, which is the framework with which we're going to build our AIs, and many other packages are already pre-installed. And even if we have to install some packages, well, this will be super easy. You will see you basically won't have any trouble getting the required packages to build our AIs. So that's really awesome. If you're a beginner in AI, trust me, we should totally do this in Google Colab. And speaking of Google Colab, well, right before this tutorial, I gave you a link. I actually just copied this link, so I'm gonna paste it right now with you so that I can start from scratch with you. So I'm gonna paste this link in a new tab. Here it is. I'm entering it, and this will take us to the folder containing all the codes of this AI A to Z course. And so it's divided in three parts. Part 1, Deep Qlearning, containing the Deep Qlearning code. Then part 2, Deep Convolutional Qlearning, containing the code that implements the Deep Convolutional Qlearning model. And finally, part 3, containing the code that implements the A3C model. Alright? And of course, right now we're going to start with part 1, Deep Qlearning. And so if you go inside, you will see two notebooks. One with the complete code that implements the whole AI with all the results and everything. And one that contains the partial code, meaning the code not related to building the artificial intelligence. And that's actually going to be our starting point. We're going to open this notebook right now. Please open the notebook and you will see that inside I kept all the code cells that are not related to the core of the AI so that we don't have to re-implement them. Like, for example, installing Gymnasium, which I will introduce you right away. It is basically our playground for building the AIs. Then importing the libraries, right? We will not re-implement this together. This is not really essential. However, everything that has to do with building the AI or training the AI, well, we will implement all of this together so that you really understand how to build an artificial intelligence. All right. So that's what we will do. And then in part 3, as you can see, we visualize the results and that it's not really essential. We don't really have to implement this together. So I left the code in this partial code notebook. Okay. So we're going to have a lot of fun implementing these code cells, to create the architecture of the neural network of this first AI and then training it in these different steps. This will be super exciting. I can't wait to start the implementation. Now, before we finish this tutorial, I just want to introduce you to our playground, which is called Gymnasium. It's an amazing platform where you can build different AIs for different environments. I'm going to quickly introduce you to the essential ones. So let's start with the basics. Classic control, that's where you can build an AI, for example, to do the cart pole or the mountain car or the pendulum. Okay, so we won't do that. This is too classic. I want to do something more exciting and advanced. And well, speaking of which, let's have a look at the Box 2D environments, which is what we're going to use for module 1 with the Deep Qlearning model. Because indeed, with this whole popularity of SpaceX and building an AIs for space, well, I chose the first environment for our first AI to be Lunar Lander. And in this one, as you can see, we'll train an agent, which is this spaceship here, to land properly on the moon, between these two flags here. So this is going to be pretty fun. That's going to be for module 1. Then for module 2, we're going to have fun with the Atari environment. But first, let me quickly show you, the other environment. So you have toy text also, where you can, for example, train a taxi, like a self-driving car, to navigate in a map. Then you have the Mujo core environments, which are pretty cool, but which I covered in another course, so we won't use them for this course. But for example, you can train an ant to walk on a certain field, or a half cheetah to walk, or even a humanoid to walk. This is covered in other courses of ours, so we won't do that in this course. But what we will do is even more fun, in my opinion. You'll tell me what you think. We're gonna train some agents to play the famous and popular Atari games. You remember when we were kids, we used to play those games, and well, that's exactly what we're gonna redo today, but this time with an artificial intelligence. And so, for Module 2, what is the game I chose? Well, let me show you. Let's click See More Environments here. I chose for Module 2. I'm sure you know this game. I'm sure you played it in your childhood or even still now, because personally I really like it and I would still play it today. I'm talking about, let's see where it is. I'm gonna scroll down a bit more. I'm talking, of course, about Pac-Man. We're gonna train an artificial intelligence to play Pac-Man in Module 2. And then finally, what did I choose for the last AI we're going to build in this course, the A3C model in Module 3? Well, I chose something that we probably all like. I don't know if you liked the Matrix movie with this famous quote of Neo saying, "I know Kung Fu." Well, in Module 3, we're going to train an AI to be able to say, "I know Kung Fu." Because indeed, the environment that I chose for Module 3 is exactly this one. Kung Fu Master. We're basically going to train an artificial intelligence to be able to fight Kung Fu against another agent. Alright? I hope you're excited about all this. That marks the end of this introductory tutorial on all our practical activities we'll do in this course. And of course, at the end, we'll also have another practical activity for LLMs. This will be a lot of fun because this is the AI of today that you also need to know how to build and how to handle. So there you go. I look forward to now starting the implementation of our first AI for our first module, Deep Qlearning for Lunar Landing. Hello my friends and welcome to this new tutorial of Module 1 on Deep Qlearning for Lunar Landing. So in the previous tutorial we got access together to this partial code of our Deep Qlearning implementation. However, now we're going to start coding, we're going to start running the cells, and therefore it's very important to understand that this notebook here is a read-only notebook. Therefore, you can't make any modification, and that's for the obvious reason that you all have access to this notebook, and therefore no one should modify anything. However, now we will create your own copy of this notebook, which will be created inside your Google Drive folder. And that's exactly why I told you in the previous tutorial that you need a Gmail address in order to use Colab. Because indeed, in order to use Colab, you need to have a Google Drive, which you can only have with a Gmail address. All right. So let's create this copy now. To do so, we simply have to go to File here and then click Save a Copy in Drive. And this will indeed create a copy of this notebook inside your Google Drive folder. I'll show you right away exactly where it is. So actually, if you open a new tab here and then go to your Drive, well, you will see this new folder, Colab Notebooks, inside which you will find, well, this copy of our Deep Qlearning implementation that you just created in your Google Drive. All right. And this one, you can modify it. And so now what we're going to do is rename this. We're going to remove the copy here because it's anyway now in your own Google Drive. And now if you want, what you can do is create the same structure of the course, with those 3 folders. Feel free to do that if you want to. Or, you can just keep your different notebooks in this Colab Notebooks folder, just like that, okay? Feel free to do however you prefer. And so now we're going to go back to, well, this notebook copy we just created. If I refresh it, it will be renamed Deep Qlearning for Lunar Landing partial code. And now we can modify it because now it belongs to our Google Drive folder and therefore we are the owner of this notebook copy. All right, and that's it. Setup done. We can now start the implementation. Not only that, we can also run the cells. And speaking of which, well, that's going to be our first step here. The first cell we have to run is to install Gymnasium because, as I told you in the previous tutorial, indeed, most of the packages are already pre-installed inside Colab, except some of them like Gymnasium. So here, we're going to install Gymnasium. Then we're going to install the Atari environments from Gymnasium. And then same for the box to the environments from Gymnasium. All right, so this will just install this. I'm going to show you right away that this will work with no issue at all. In order to run the cell, you simply need to click this play button to run the cell. And you will see that it will install Gymnasium and the environments here of Atari and Box2D with absolutely no issue. Let's check it out. Now, as you can see, it's downloading some, dependencies and packages, installing collected packages, Fireman notifications, successfully installed Fireman notifications. Now downloading another license, which is needed for Gymnasium and the different environments. It also downloaded Shimmy, AutoROM, installing build dependencies. You see, you have nothing to worry about. Everything is getting installed successfully with absolutely no issue. Whether you are on a Linux or Mac or Windows, you don't have to worry about, opening a terminal or command prompt and installing the packages that we will use for this course. Here, nothing to do. Everything is fine. Now it's installing the Box2D environments for Python. And in a second, we will have everything, Gymnasium related installed properly for this notebook so that we can build and train our AI in the Gymnasium environment. Now it's almost done, should be done in a few seconds, and then we'll be good to go to run the next cell to import the different libraries. But let's just wait for this to finish. It's going to be finished imminently now. And there you go, successfully build Box2D PY, installing collected packages, swig Box2D PY, and there you go, successfully installed the Box2D environments and the Atari ones. Alright, so you see, no problem at all. That's the beauty of Google Colab. We just have to run a cell and this installs everything without having to open any terminal or command prompt. Alright, now let's run the next cell, which is about importing the libraries. So let me quickly explain what the libraries will be used for. So this is for the operating system. This is because we will use some random parameters, random variable generators. This is NumPy in order to work with arrays and mathematics. This is of course the Torch library because we will build and train our AIs with PyTorch. Therefore we import the Torch library first, then we import the NN neural network module from the Torch library, then the Optim module for the optimizer when training the AI again by the Torch library, then functional because we will use some functions during the training, again this is from the neural network module by the Torch library, Autograd same, another module by the Torch library for the training again, more specifically stochastic gradient descent. Then variable in order to create some Torch variables, we will see that later on in the course. And then finally these modules from the collections library, which will be used indeed during the training. Alright, so let's run this cell as well. In order to do so, we simply have to click this play button to run the cell and this will import all the libraries. And by the way, as you can see, we didn't have to install any of these libraries. That's exactly what I was telling you in the previous tutorial. All these libraries are already pre-installed within Colab. So we don't even have to do those pip install, right, like we did for Gymnasium, for the Torch libraries, right? That's the beauty of Colab. Here, everything is already pre-installed, so we only had to import them. All right, so that's it. That's it for the setup. Now we are ready to do our first implementation in part 1, building the AI, and more specifically, creating the architecture of the neural network. And well, that's exactly what we'll do in the next tutorial. So are you ready to get your hands on building an AI? If yes, well, join me in the next tutorial where we'll create the architecture of our first AI here, which will be trained later on to land properly on the moon. Hello my friends and welcome to part 1, building the AI, where we're going to create the architecture of our neural network. Are you ready? Let's do this. So we're going to create a new code cell here, inside which we're going to create a class, which will therefore contain the whole architecture of our neural network, meaning the brain of the AI. So here we go. We start with class, then we're going to name this class network, or you could call it neural network or brain if you want, because it represents the brain of the AI. And then we're just going to use a feature of object-oriented programming, which is inheritance. I recommend to look online if you don't know what it is, which basically allows us to inherit from the tools of another class, which is the module class from the NN module, so that we can build a neural network. All right, so how does it work? Well, we call our NN neural network module, from which we're going to call another class, which is called the module class, which is the class from which we want to inherit all the features of this class. Alright, so let's press enter, then let's add a colon, and then here we go. We're going to start, of course, with the init method. Alright, just like in any class. And, well, I just pressed enter. You see, that's the assistance of Google Colab. That's good. You probably got the same, so there we go. What do we have to input here in this first argument? Well, it's going to be the state size. What is the state size? That's simply the number of inputs in a state. And to exactly know where it is, well, we have to have a better look at our environment, which I remind for module 1 is lunar lander. We're going to train an AI to land properly on the moon between those two flags here. And well, here is a nice description of the lunar lander environment. What is the action space? Discrete 4. That means that our AI has 4 possible actions that it can play. And then for the input, well, let's see a better description here of the observation space. As you can see, the input state is a state of an 8-dimensional vector, which are the coordinates of the lander in x and y, then its linear velocities in x and y, so that's for its speed vector basically, but we also have its angle, then its angular velocity, and 2 booleans that represent whether each leg is in contact with the ground or not. Alright, so that's the whole observation space, an 8-dimensional vector describing at each time step, well, the state of the AI, the agent, all right? And then we can also see a better description of the action space. I remind that there are 4 actions. The first one is 0, do nothing. The second one is 1, fire left orientation engine, basically move to the left. Then second action of index 2 is fire main engine, basically continue in the same direction. And then finally last action of index 3, fire right orientation engine, meaning move towards the right, all right? So you see better how the action space and the observation space is described. Then we'll have a look at the rewards when we do the training. But for now, we will only need those information of the action space and the observation space. So here we go. Let's go back to our implementation. And therefore, here, as we perfectly understood, well, the state size is going to be 8. But we don't have to specify 8 yet. We will do when we call the network class later on in the training. Alright, then this argument is going to be for the action size, which I remind is, as we just saw, 4, right? 4 actions. And then we're just going to add a default seed of 42, just to fix a seed for the randomness. And we'll see if we use 42 in the future. Then here, that means that nothing will be returned. And actually, you can either choose to keep it or delete it. And then here, next row, well, the purpose of that row is to activate the inheritance. Here, we don't have to specify anything in the init function. However, in super, we're going to enter as argument network and self. And that's just in order to activate the inheritance. All right, and now that's where things get interesting. That's where we're going to start building the architecture of the neural network. But first, we're just going to activate the seed super quickly with self.seed equal, and then we're going to use a function by the torch library, which is going to be manual seed. We're going to find it here. There we go, manual seed. And then, of course, in parentheses, we're going to enter the seed argument that is right here in our arguments. So that's just to generate some random factors. And now, there we go. We start with the architecture of the neural network. All right, so let's do this. Let's start from the first full connection between the input layer and the first fully connected layer. And therefore, the first variable I'm creating here is going to be FC1, representing the first full connection between the input layer and the first fully connected layer. All right, and so how do we create that? Well, we call our NN neural network module, from which we're going to call the linear class, which we can get thanks to the inheritance from NN module. And what do we input in this linear class? Well, first, the first argument is the number of neurons in the input layer, basically the state size. And then the second argument is going to be, of course, the number of neurons in the first fully connected layer. All right, so for the first argument, there we go. We enter the state size. Perfect. And then, now, big question is, what is going to be the number of neurons in the first fully connected layer? Well, there is no rule of thumbs to immediately tell what is the optimal number of neurons in the first fully connected layer. I'm just telling you that there was a lot of experimentation to build a performance AI that manages to land properly on the moon. And the optimal number of neurons that was found for this first fully connected layer is actually 64. All right, but of course, there was a lot of trial and error before finding that optimal number of 64. Okay, and that's it. That's it for the first full connection, FC1, going from the input layer to the first fully connected layer. So now I'm going to copy this. I'm going to paste it just below in order to create the second full connection. There we go, FC2. And so now, according to you, what is going to be the first argument here? Well, that's obviously going to be the number of neurons in the first fully connected layer, therefore 64. And then what is going to be this number here in the next fully connected layer? Well, that depends if we want to have just one fully connected layer or another one. If we want to have just one fully connected layer, then the number here would be the number of neurons in the output layer, meaning the number of actions, meaning 4. Or if we want to have another fully connected layer, well, we would have to specify the number of neurons in this new fully connected layer. And, well, actually, again, through a lot of experimentation, trial and error, we realized that the best architecture contains a second fully connected layer, which actually contains, again, 64 neurons. So we actually keep it like that. That's our second full connection between the first fully connected layer and the second fully connected layer. And so now, finally, I'm going to copy this line again and paste it right below. I'm going to call this third full connection, of course, FC3. It is going to have as a first argument the number of neurons in the previous fully connected layer, therefore 64. And however here, what is going to be the new number of neurons? Well, again, the question is, do we want another fully connected layer? And this time, no. Actually, the best architecture contains two intermediate fully connected layers between the input layer and the output layer. So there we go, we stop here. We can directly finish with the output layer containing the action size. And well, therefore, the argument here is going to be action size, which I remind for our lunar landing environment is going to be 4. All right, but for now we say action size. All right, and that's it. That's it for the architecture of our neural network. Congratulations, you just built a powerful neural network, which is actually the brain of our AI, which then will return some action to try to land on the moon. So that's going to be it for this tutorial. In the next tutorial, we will make another function to forward propagate the signal from the input layer to the output layer. I can't wait to do that with you in the next tutorial. And until then, enjoy AI. Hello my friends and welcome to this hands-on tutorial where this time we're going to build the forward method inside this network class, which will forward propagate the signal from the input layer to the output layer through our two fully connected layers. Alright, let's do this. So we're going to call this function forward, which is going to take as input, well, first self, and then according to you, what is the main argument that this forward function will call as input? Well, that's of course going to be the state, because it's going to propagate the signal from the state to the output layer in order to play a certain action at a certain time step. All right, so here we go. First, we're going to propagate the signal from the input layer to the first fully connected layer. And how we're going to do that? Well, we're going to use our FC1 object, right? Because this is an instance of the linear class, therefore returning the first fully connected layer. And so right here, I'm going to take this self.fc1, the first full connection. I'm going to paste that here. And of course, it takes as input the state, the current state at a certain time step in the environment. And since FC1 state actually returns the first fully connected layer, well, we're going to create a new variable here, which will contain exactly what is returned by self.fc1 state. Then we're going to have to activate this signal thanks to a rectifier activation function. And to do so, we're going to update the value of x by calling first the f shortcut that we actually imported before when we imported the libraries. It is right here. It is actually the functional module from the NN module by the Torch library, which we shortcut as f. Okay, so that's just in order to call the functional module. And so from this functional module, we're going to call one of its functions, which is the relu function, representing, of course, the rectifier activation function, which takes as input x. And that, meaning these two lines of code, actually propagate the signal from the input layer to the first fully connected layer with a rectifier activation function. And so now we're going to copy this because we're going to do exactly the same for the second part of the forward propagation, meaning from the first fully connected layer to the second fully connected layer. And so I'm copying this. And here, of course, we just have to replace FC1 by FC2. And then, of course, state by x, because the second full connection FC2 takes as input the signal from the first fully connected layer and will return the signal in the second fully connected layer. And then, of course, we keep this. We're going to still activate our neurons in the second fully connected layer with a rectifier activation function. All right, perfect. And now let's take care of the final part of this forward propagation, which is to finally return the final signal in the output layer containing our actions. And to do so, well, we can finish with a return, and then we call our third full connection FC3, which takes as input, of course, X, which is now fully activated with our rectifier activation function through the first fully connected layer first, and then the second fully connected layer. And there we go. That forward propagates the signal from the input layer containing the state to the output layer containing our actions, and we're done basically creating the architecture of our neural network. Alright, so you see the beauty of PyTorch? We created this architecture super efficiently. We now have our brain, we now have the brain of the AI, which therefore is able to be trained in part 2, training the AI. So whenever you're ready, let's do this. Now, we're not going to forget to run our cell, right? This beautiful cell we just implemented together. So here we go. We just have to click this play button here to run the cell, and perfect, the cell was executed successfully. Alright, so join me in part 2 to train the AI whenever you're ready, get some energy, and I'll see you super soon to start this training implementation. And until then, enjoy AI.